For section 5.3, we're going to be talking about medians and altitudes of triangles today. And a median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. And every triangle has three medians, and medians are concurrent. For concurrent means that three lines are where all three lines meet at one point. So in the picture to the right here, I have a picture of one median of the triangle. So it's starting at the top angle and it's going down to the opposite side at the midpoint of that segment. So there is also a median that would start over here and go to the midpoint here. And then this one would go to the midpoint here. And I know that's not the best drawing, so attempt this again. But they will all meet at one point. But that is what a median is. The centroid of the triangle, or the center of gravity, is the point of concurrency of the medians of a triangle, so that point where they all meet. And these are always inside of the triangle. So then we have what is called the centroid theorem here, and that says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So the first one here, it says AP, segment AP, which is right here, is 2/3 of this whole line. And BP, let me erase that one. BP is here, and it is 2/3 of BZ. And then CP is 2/3 of the entire line CX. So this theorem proves that, or tells us that we can figure out those lengths using those formulas there. So in example 1 here, we have triangle ABC, and they're telling us that segment AF, so that whole segment, is 9. Trying to figure out where I want to label it there. And GE, so from G to E, this little guy is 2.4. Find each length. And the first one is asking us to find AG. So AF is 9. We need to find AG, which is the shorter piece here. So we know, we just learned with that theorem, that AG is 2/3 of AF. So we could take 2/3 and times it by 9. And I'm going to make it into a fraction to multiply. 3 and 9 on an angle here have a 3 in common, so I'm going to divide both by 3. And then I'm going to multiply across the top. 2 times 3 is 6, and at the bottom, 1 times 1 is 1. And 6 over 1 reduces to 6. So segment AG is 6 units. Then they're asking us to find CE. So let me erase that part. All right, CE is this part, and they gave us from G to E was 2.4. So we know that 2/3 of that CE segment, and I'm just going to call it CE, but 2/3 of CE is going to equal 2.4. And we have to figure out what CE is. So we're going to divide by 2/3 on both sides. So the 2/3 will cancel. And then we have 2.4 divided by 2/3. 2 and 4/10 would be 2 and 2/5. And that would be 12 over 5 if I made it improper. So I'm going to rewrite that. I'm going to make it look like this. And division, for division with fractions, we're going to keep, change, flip. So I'm going to keep the 12/5, change to multiply, and flip the 2/3 over. And before I multiply, I want to reduce the 12 and 2. So I'm going to divide both by 2. And I'm going to get 18 at the top and 5 at the bottom. 5 goes into 18 3 times with 3 left over. So 3 3/5, or 3.6. is the entire length of that line. All right, the next one, for example 2 here, it says the diagram shows the plan for a triangular piece of a mobile. Where should the sculptor attach the support so that the triangle is balanced? So in order for it to be balanced, we need to attach it to the center of gravity, which is also called the centroid. So the centroid, remember, is the point of concurrency of the medians. So we have to find that point where all the medians meet in the somewhere near the center of this triangle. So we have to find the midpoint of some of the sides here. So I'm going to find the midpoint of segment QR right now. And remember, to find the midpoint, we take the x coordinates, which in this case would be 0 and 6, and we add them together and divide by 2. And then to find the y coordinate, we take the y's, the 8 and the 4, add them together and divide by 2. So 6 over 2 would be 3, and then 8 plus 4 is 12. 12 over 2 would be 6. So the midpoint of segment QR would be 3, 6. So that would be right here. Oops, if I can draw it a little bit better there. So that median would look like that. And then let's find the median of QP. I'm going to do that in pink. From Q to P, the x's would be 0 and 3. We have to divide those by 2. And then the y values would be 8 and 0. Oops, 8 plus 0 divided by 2. So 0 plus 3 divided by 2 would be 3/2, which is 1.5. And then 8 plus 0 is 8, divided by 2 would be 4. So this midpoint is 1.54. So over 1.5 and up 4. So it would meet right about there. So the centroid there is at the black dot, and the coordinates of that point would be 3, 4. So that is where they would want to attach a support so that triangle would be balanced and lay flat. Okay. Altitude of a triangle is when we have a perpendicular segment from a vertex to the line containing the opposite side. The altitude can be inside, outside, or on the triangle. So depending on what the triangle looks like, what kind of triangle it is, the altitude could be anywhere. So here's a little diagram is showing you the altitude of 2 different types of triangles. So you're taking one vertex and drawing it down to the opposite segment. And sometimes you have to extend that segment, like this one right here, to meet that perpendicular segment. But over here, as you can see in this triangle, it went straight down to the opposite segment. You didn't have to add anything. So depending on what the triangle looks like, you might have to do that. The orthocenter of a triangle is where the altitudes of the triangle meet. So as you can see here, all 3 are drawn, and they meet here at point Q in this picture. So for our last example here, we need to find the orthocenter of triangle JKL with the given vertices. So I already went ahead and drew the triangle for us. Well, I am going to start off by drawing the altitude from point K down to JL, because that is the easiest one, because it's a straight line straight down so that it's perpendicular to that opposite side. And that segment has an equation. It is x equals -2. It's a straight line through the x-axis at -2. So in blue, the equation is x equals -2 for that altitude. And then we're going to have to find the altitude from one of the other points. So in order to be the altitude, we have to know it's perpendicular to the line. And with those lines being on an angle, it's very difficult to tell that and make it correct. So we do know that perpendicular lines have the slopes, when you're multiplying the slopes together, they have a product of -1. So if I know the slope of one of the lines, I can find the slope of the perpendicular line. So I'm going to pick KL, and I have to find the slope of KL. So I am going to go from L up to K and over. So that means I would go up 4, and I'm going to go over 4 here, but that's back 4. So up 4 and back 4. Remember, rise over run would simplify down to -1. So then that means that the slope of the perpendicular line to that would be a +1, because -1 times +1 gives us that -1. So in order to be perpendicular to this line KL, it has to come from the point J, because it has to come from the point across opposite of that segment. And we're going to have a line with a slope of 1. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. So I'm going to try my best to draw this line here. It's going to have that line. To find the equation for this line, so we know a point and we know the slope. So we know point J is -4, 2. So I'm going to use point slope formula. So y minus y1 equals m times x minus x1. The slope is 1. Our ordered pair is -4, 2. So x is going to be -4. So that's actually going to turn into a +4 there. And y is 2, so -2. I'm going to distribute that 1, so we're going to have y minus 2 equals 1 times x is x, and 1 times 4 is 4. And then we're going to add 2 to both sides, so I'm going to have y equals x plus 6. So now, even though we can look at this triangle and see that point where they meet is at -2, 4, sometimes you're not going to be able to do that with your shape, your triangle that you have. So you're going to have to solve a system with the two equations that you create. So we have x equals -2 and we have y equals x plus 6 for our two equations for our two lines. So we need the ordered pair where these two equations meet. Well, we already have the x value of -2, so I'm just going to plug that in to the other equation. -2 plus 6 would give us 4. So -2, 4. So it wasn't too much extra work to prove that that center, that point is -2, 4.